Hey guys, I'm going to go over the homework for this weekend, but and those of you that are just like you understood what we did in class, then you can go ahead and fast forward and go to the part where I actually go over numbers 10, 20, and 21. So number 10, then 20 and 21 is for homework. But just as a quick review for some of you that might be struggling, I just wanted to quickly just maybe review what some of these other ones mean. So if you look back at your notebook and take a look at page 99, okay? This says proportional or not. And then we said, okay, if you have a graph, the way you know a relation is a graph, or a graph is proportional, that's it has to pass two criteria. It's linear, which means it's straight, and it passes through the origin. If those two things are true, then this is proportional. Now, in a table, if you have them, the way you tell whether it's going to be a line or not is you look at the y over x, y over x. And all the values, except for the 0, 0, 1, the y over x have to be equal. So if their ratios, what I mean by that is you take the y and put it over the x. Then you take the next y, put it over the x. Don't use the 0 and 0 because that's a special case, okay? And then if the table was longer, then you put the next y over the next x, and so on and so forth. And every single time when you divide the y by the x, divide by the y by the x, it should come up to be the same value if it's going to be proportional. If the numbers come out to be different, like let's say this is -5 and this is like a +5 or a 2 or -1/2 or something where they're not the same, then that means this is not linear. It's not proportional. So when you're given a table, look for the origin, and then you have to do the work of checking y over x, and then you'll be able to figure out whether it is proportional or not. Now let's say you have an equation. So all of these are equations. The way you can tell if it goes to the origin is if its initial value is 0. So any of these, the ones that go to the origin is like this one, this doesn't go through the origin, this one does, and this one does. Okay? But that's not enough. Then you have to check if the relation is linear. So this is also linear. It has an initial value of 0. Imagine there's an invisible 0 here. And then it's linear because the exponents of both x and y are 1, and neither of them are in a denominator. So here, this is not proportional because even though its initial value is 0, it's not linear because of this x having an exponent other than 1. And then this one is, though it's linear because the exponents of both x and y are 1, and neither of them are in a denominator, because the initial value is 2 instead of 0, this is not proportional. Okay, this next one, if y happens to be equal to 2/3 x, and then that means a plus 0, that you have an initial value of 0. And then if you look at the x and the y, they both have an exponent of 1, and neither of them are at the bottom of a fraction in the denominator, so this is proportional. Here you can notice right away that even though the x and the y both have an exponent of 1, the x is at the bottom of a fraction in the denominator, and even though the initial value is 0, the fact that the x is at the bottom makes it nonlinear. And if it's not linear, then it cannot be proportional. Okay, even if its initial value is 0. So we practiced that on that worksheet, right? So this is all page 99. You can use that, keep it open next to the paper. But if we go to number 14 or number 10 in the back, we've got a table. So that's this situation, right? We need to look for the origin, and then we need to do y over x, y over x. So number 10, it already it's passing through the origin because we see 0, 0. Now we need to do y over x. So y over x, and then y over x, not x over y, okay? So if we do that, we go 5 over 1, this y over that x, then 10 over 2, and then 15 over 3. Now if I simplify that, okay, if I take 5, and if you want to check it in your calculator, you can, but if you do 5 divided by 1, the answer is 5. 10 divided by 2, the answer is 5. 15 divided by 3, the answer is 5. That means these are proportional. Since all the ratios are equal, because they all equal 5, and this relation passes to the origin, then it is proportional. So yes. Okay? This relation passes through what? Right. The origin. And what else has to be true? All the y over x ratios, so we did that ratio, then that ratio, then that ratio, are equal, which makes this relation proportional. Okay? So that's number 10. Now, if that was too fast and you need time to write this, or erase it and see, or put it on a separate sheet of paper, how would you explain why this is truly proportional? Okay, you don't have to use my words exactly, but this is giving you an idea of how. Now let's go down to 20. So if you're given an equation on page 99 of your interactive notebook, it's this situation, right? You're looking for the initial value being 0, and then you're looking that it's linear, which means both x and y have an exponent of 1, and neither x nor y are in the denominator of a fraction. So none of these have fractions, but you still have to check, the exponent. So this is linear because the x and y are both have an exponent of 1. And neither of them are in a denominator, so that passes the linear test. But now, does it pass the initial value test? No, it does not, because the IV here is 1. It's supposed to be 0. So the answer is no, although this equation is linear. We know that much. It passed the linear test. The initial value is 1 instead of 0. And if you want to go a step further and say, therefore, which is why this is not proportional, which is why this equation is not proportional. You can continue and add on that concluding little phrase if you want. All right, number 21. This one has an initial value of 0, but it's not linear because that one of the variables has an exponent other than 1. So I can say, although this equation has an initial value of 0, although this equation has an initial value of 0, it is not linear because the x has an exponent 2 instead of a 1. Okay, something like that. So once again, I would strongly suggest that if you struggle with this, go back and listen to the video. And you know what you can do is like sometimes pause the video and guess what I'm going to say next. How am I going to finish my sentence? That'll help you get thinking like mathematically. So yeah, so that's the end of it. Numbers 10, 20, and 21 was for homework, and it's due on Monday the 4th. This is the end of the video.